So today let's explore the battery pack from the vacuum cleaner from the previous video. It's a battery pack made by LG Chem. It's 25.55 volts, 2000 mAh, 51.1 watt hours. And it's made in 2017-07, so it's 6.5 years old. So let's see what's inside of it and also how much the cells degraded since then. And how they came out of balance and so on. Another label here on it. 2 cables, the main positive and negative, and another 4 wires that went into the control board of the vacuum cleaner. But now let's open it and see. There is some sort of a heat shrink on it. This comes off, and you can see 18,650 cells in it. 6 so far, and 7, which makes sense given the voltage and that each cell is typically about 3.6 or 3.7 volts. This comes off. There is also a board in it. Here's the control board, 7 cells and positions for 2 extra cells which are not used. Of course the cells are in a series in it, and there is also a fuse, which looks like a typical car fuse. It's in a series with the positive. And now let's remove the control board. Does it come out or is it soldered onto something? The board doesn't want to come out because there is a connector on it with short wires. Now it's disconnected. Another connector here. And that's it. There's a lot of it on it. 7 chips plus again 2 empty positions. This was meant for up to 9 cells apparently. These chips are probably monitoring individual cells and balancing them maybe. And a lot of other chips. Some diode. I have no idea what these are. Some transistors. A lot of resistors and capacitors. Even more transistors. A 6-pin chip. And nothing on the other side. There was a 4-wire interface going into the control board of the vacuum cleaner. And this connector which went into the board actually has 8 wires, which makes sense for 7 cells in series, the positive, negative and the 6 tabs on the battery pack. And plus some temperature sensor here, I guess, sending the temperature somewhere between the cells. If anybody's interested in the markings, this, the diode, probably just transistors. And some chip here. And that's it. Checking the balance. The lowest voltage one is 4 volts exactly, and the highest voltage one is 4.025 volts. 25 millivolts in balance. Here's the fuse, which is 10 amps. And if you're interested in the marking of the battery, it actually doesn't say the capacity, but it's just in a series, nothing in parallel, so it should be 2000 mAh as the entire pack. Let's fully charge it and then let's measure what comes out of each individual cell. Now the battery pack is fully charged and let's measure the individual cells in it. And the first cell is in the process of discharging at 500 mAh down to 3 volts. And it shows 1872 mAh. So there's still most of the capacity left. So that's the capacities in mAh of each cell and the energy in them in watt hours. And this one was the highest one and this one the lowest one. And the lowest one is just 1.8% less capacity than the highest one. So it seems to be quite uniform. And there might be some bias in the measurement because the lowest measuring one was actually measured the last one. And the highest one was the second one. So this one had more time to self-discharge and the measurement might be skewed against it. And if the cells were originally 2000 mAh, the degradation isn't really that bad. Or maybe they were 2150, according to some data on this type on the internet. But the label says 2000. And here's the average capacity, and this is 93.3 out of 2000 mAh. So the degradation isn't really that bad. Even though, of course, in a series connection, the milliampere capacity of the entire battery pack is limited by the worst cell, which means there is 92.45% left of the capacity of the battery pack. The average number would apply if it was all in parallel. So that's it, the degradation isn't really that bad after 6.5 years. And of course in the vacuum cleaner video I was calculating the operating time of the vacuum cleaner based on the current draw of the motor and the capacity of the battery pack. and the calculated time was less than the product claims. But somebody in the comments suggested it's actually because the current draw of the motor goes up and the new motor might have drawn less current, which makes sense. The motor might have developed some short turns in the windings, for example, but even more likely, the bearings are seizing up. They have more friction than a new motor. They're dirty, not lubricated. The material wears. It's just a sleeve bearing. The vacuum cleaner claimed 65 minutes of operation, and I guess for marketing reasons it's at the lowest setting, but I calculated about 42 minutes, which might mean the motor now draws 50% extra current, which doesn't seem impossible looking at the dirty bearing here, and also the RPM I measured might be lower than the original. That's it, and if you like my videos, please consider supporting this channel on Patreon, using the thanks button and subscribing. And big thanks to all of you who already support me. You're making this channel possible.